Welcome to Sleepy Crimes. I am Anna, your host. Tonight, we drift into the shadows of the Cascadia Subduction Zone, a place where the Earth itself seems to hold its breath in a perpetual state of waiting. Imagine the Pacific Northwest, where the air is a thick, cool blanket of mist that smells of damp earth and salt spray. We are standing on the edge of the world, where the deep indigo waters of the Pacific Ocean meet the rugged, emerald coastline of Washington state. It is a land of giants, of lofty firs and ancient cedars. But today, our journey takes us away from the vibrant greens of the living forest and into the pale, haunting silence of the ghost forests. Here, the landscape is punctuated by the silver-gray remains of trees that have stood as silent witnesses for hundreds of years. They are the whispering stumps, stripped of their bark, their branches reaching like skeletal fingers toward a heavy, overcast sky. The wind here doesn't howl. It sighs through the cracks in the weathered wood, carrying with it a story that was forgotten by history for nearly 3 centuries. As we begin our descent into this mystery, feel the chill of the morning air on your skin and the soft, yielding dampness of the marsh beneath your boots. We are stepping back in time to uncover a secret buried in the mud, a secret that redefined everything we thought we knew about the ground beneath our feet. Let us travel back in our minds to the late 1980s. The world was different then, yet the Kopali's River flowed much as it does now, snaking through the lowlands like a ribbon of molten lead under the weight of a pewter sky. In a small, weathered canoe, a geologist named Brian Atwater paddled slowly through the salt marshes. The only sound was the rhythmic dip of his paddle into the dark water and the occasional, lonely cry of a heron overhead. The water here is brackish, a mixture of the fresh river flow and the encroaching tide, and it carries the heavy, stagnant scent of sulfur and brine. As Brian moved deeper into the wetlands, he was surrounded by hundreds of dead western red cedars. These were not fallen logs rotting into the earth, but upright trunks, standing firm in the salty muck. Their wood was bleached to the color of bone, smoothed and polished by years of relentless wind and rain. To a casual observer, they might have seemed like a natural part of the landscape, perhaps killed by a slow, gradual change in the river's path. But to Brian, they looked like a crime scene frozen in time. He could feel the weight of their silence, a heavy, expectant quiet that seemed to demand an answer. The marsh felt like a graveyard where the headstones were the very victims themselves, preserved in a state of perpetual, ghostly mourning. Why did they all die at once? Why were they still standing, decades or even centuries after their last needles had fallen? He leaned forward in his canoe, his eyes searching the muddy banks for a clue. Brian stepped out of his canoe, his boots sinking into the thick, dark mud of the riverbank with a wet, sucking sound. The mud was cold and clung to his legs with a persistent, heavy grip. He carried a simple tool, a trowel, and began to dig into the side of a bank where the river had eroded the soil, exposing the secrets of the past. This was not a quick process. He worked with the patience of a man who knows that time is measured in layers of earth. He scraped away the surface silt, revealing a history hidden beneath the roots of the grass. First, there was the modern layer, the dark, organic peat of the current marsh. But as he dug deeper, he found something startling. A sharp, distinct line separated the dark marsh soil from a layer of pale, sandy forest soil beneath it. This was the contact. It was as if someone had drawn a line with a silver ruler across the history of the earth. Below that line, the roots of the dead cedars were still firmly planted in the rich, loamy soil where they had once flourished. They hadn't died from old age or a slow change in the environment. They had been plunged, almost instantaneously, into the killing salt water. The evidence was there in the very grain of the earth. A sudden, violent transition from a thriving forest floor to a saltwater grave. The smell of the ancient soil, released after centuries, was rich and musky, a scent of a world that ended in a single heartbeat. The realization began to take shape in Brian's mind, as steady and undeniable as the incoming tide. For these trees to die in this specific way, the land they stood upon must have dropped, not by inches over many years, but by several feet in a matter of minutes. This phenomenon is known as subsidence. Imagine a massive, unseen force beneath the crust of the earth suddenly letting go. The Cascadia Subduction Zone, a fault line stretching from Vancouver Island down to Northern California, had long been thought to be dormant, a quiet giant that posed no threat. But the ghost forests whispered a different story. They told of a time when the North American plate, snagged on the subducting Juan de Fuca plate, finally snapped. In that moment of cataclysmic release, the coastline buckled and sank 6 feet into the earth. The majestic cedars, once high and dry on the forest floor, found their roots drowned in the salt of the ocean. The transition was so fast that the trees didn't have time to rot away. The salt water that killed them also acted as a preservative, pickling the wood and holding it in a state of suspended decay. As Brian looked up from his muddy trench at the silver skeletons surrounding him, he wasn't just looking at dead trees anymore. He was looking at a clock that had stopped at the exact moment of a disaster, so large it defied human memory. The silence of the marsh was no longer empty. It was filled with the echoes of a prehistoric roar that shook the very foundations of the continent. Through the work of Brian and his colleagues, the date of this catastrophe was finally pinned down. Using the rings of the trees, like a thumbprint of time, they discovered that the cedars had all died during the winter of 1699 to 1700. Across the ocean, Japanese records spoke of an orphan tsunami that arrived without warning on the 26th of January, 1700. The pieces of the puzzle clicked into place. These whispering stumps were the primary evidence of a magnitude 9 earthquake that had rewritten the geography of the coast. Today, they stand in the quiet estuaries of the Kopali's River, their gray wood glowing softly in the twilight. They are monuments to a night of terror, yet they offer a strange sort of peace. They tell us that the earth is alive, that it shifts and breathes, and that even in the wake of total destruction, something remains. The salt marshes have claimed the land, and the herons still fish among the roots of the fallen. As the fog rolls in from the Pacific, blurring the lines between the water and the sky, the ghost forest disappears once more into the mist. We are left with the quiet, the soft lapping of the water against the silver wood, and the knowledge that some stories are too powerful to stay buried forever. Close your eyes now and listen to the stillness. The trees have told their tale, and the marsh is at rest. The scene begins on the far side of the great ocean, thousands of miles away from the silent, drowning forests of the West. It is the middle of a winter night in the year 1700. The air along the eastern coast of Japan is biting, a sharp, crystalline cold that settles over the thatched roofs and narrow wooden paths of the coastal villages. In the era known as Genroku, the moon hangs like a pale, polished coin above the Pacific, casting a silver sheen over the restless water. People are tucked away in their homes, the warmth of charcoal braziers fading into the quiet of sleep. There is no tremor in the earth here, no sudden jolt to rattle the ceramic tea sets or sway the heavy, weathered beams of the houses. The ground remains steady, anchored and still. The only sound is the rhythmic, distant pulse of the sea, a familiar lullaby for the fishing communities that have lived beside these waters for generations. Yet, as the clock approaches midnight, the sea begins to behave with a terrifying, inexplicable rhythm. The water does not arrive with the roar of a storm or the crash of a gale. Instead, it moves like a ghost, silent and heavy, pushing its way onto the land where it does not belong. The moonlight reflects off a surface that is rising higher and higher, far beyond the reach of any normal tide, as if the ocean itself has suddenly grown too large for its basin. In the village of Kiwagasaki, the water arrives as a silent, swelling tide that refuses to stop. The villagers are woken not by a roar, but by the soft, invasive sound of water lapping against their doorframes, a cold and insistent presence. They step out of their bedding into a foot of freezing seawater, their lanterns flickering as they scramble to understand what is happening. The waves grow higher, reaching 10 feet in some places, surging through the narrow streets with a weight that pulls at the very foundations of their lives. In the chaos, a fire breaks out, the orange flames reflecting against the black, encroaching water. It is a surreal dance of light and shadow in the middle of a winter night, the smell of wet wood smoke mingling with the salt spray. 13 houses are swallowed by the waves, their timber groaning as the ocean claims them. Further south, in the village of Miho, the salt kilns are flooded, the carefully tended fires extinguished by the brine, and the rice paddies, the lifeblood of the community, are buried under a layer of sand and salt. The people flee to high ground, huddling together in the darkness, watching as the sea repeatedly retreats and returns, a pulse of energy that seems to come from nowhere. As the hours pass and the sun begins to lift over the horizon, the extent of the mystery deepens. In Nakaminato, a great ship carrying hundreds of bales of rice is caught in the strange, sloshing currents of the river mouth. The sailors, experienced men who know the moods of the sea, are utterly baffled. The water retreats until the riverbed is nearly dry, leaving the ship tilted and vulnerable, only to return minutes later with a surge that threatens to smash the hull against the rocks. This nautical struggle is recorded with meticulous care by a local merchant, his brush moving across rice paper with a steady hand despite the confusion of the morning. He writes of unusual seas and high tides that arrived without the warning of an earthquake. For 3 centuries, these records, the journals of samurai, the ledgers of merchants, and the formal reports of village headmen, will sit in archives, their ink fading, their secrets waiting for someone to ask the right question. They record the loss of houses, the damage to storehouses, and the fear of the people, all while noting the absence of any shaking of the earth. In the Japanese tongue, they begin to call it a minko tsunami, an orphan tsunami. It is a child of the ocean, with no parent earthquake to claim it. The scene shifts to the late 20th century, to a quiet room filled with the scent of aged paper and the soft hum of a computer. It is 1996. A researcher named Kenji Satake is poring over these ancient Japanese documents. He is a man of numbers and patterns, and he begins to see something that others have missed for hundreds of years. He notes the 6 different locations along a 500-mile stretch of the coast, from the far north to the Kei Peninsula. He charts the height of the waves and the precise timing of their arrival. He realizes that this orphan tsunami was not a local fluke or a strange weather event. It was a traveler. He begins a complex mathematical dance, working backward across the vastness of the Pacific. He knows that a tsunami moves at the speed of a commercial jetliner, nearly 500 miles per hour in the deep, open water. As he maps the ripples back across the globe, he isn't looking at the coast of Japan, but away from it. He is looking across the empty horizon, searching for a place where the earth might have groaned at exactly the right moment to send this wave on its 10-hour journey. As Satake calculates the travel time, the pieces of the puzzle begin to snap together with an eerie, chilling precision. If the wave reached the shores of Japan around midnight on the 27th of January, it must have begun its journey on the other side of the world on the evening of the 26th. He looks toward the coast of North America, toward the region where Brian Atwater had found the ghost forests and the buried layers of sand. The date matches perfectly. The winter of 1700. The 2 mysteries, separated by 5,000 miles of ocean and nearly 300 years of time, are actually one and the same. The orphan finally has a parent. It was a megathrust earthquake, a magnitude 9 event that ruptured 1,000 kilometers of the Earth's crust along the Cascadia Subduction Zone. This single event sent a wall of water racing toward a distant shore that had no idea what was coming, while simultaneously dropping the coastline of Washington and Oregon into the sea. The connection is undeniable. A bridge of data built across the deep blue of the Pacific, linking the dead cedar trees of the Northwest to the charcoal ink of a Japanese merchant's ledger. The ghost forest and the orphan tsunami are the two halves of a single, monumental story of the Earth's power. As Sadek calculates the travel time, the pieces of the puzzle begin to snap together with an eerie, chilling precision. If the wave reached the shore of Japan in the winter of 1700, it had to have a source, a massive tectonic upheaval that left its mark somewhere on the other side of the world. To find it, we must leave the dusty archives of Japan and travel to the damp, emerald-shrouded coastlines of the Pacific Northwest. Imagine, if you will, the silence of the Copales River in Washington state. Here, the air is thick with the scent of salt spray and decaying cedar, a heavy, cool mist clinging to the surface of the water like a wet shroud. In the late 1980s, a geologist named Brian Atwater paddled a small canoe through these tidal marshes, his eyes fixed not on the beauty of the landscape, but on the banks where the river had carved away the earth. He was looking for something hidden, something buried deep within the silken, gray mud. The water here moves with a slow, rhythmic pulse, rising and falling with the tides of the Pacific. But beneath that calm rhythm lay a record of violence so profound it would rewrite everything we thought we knew about the ground beneath our feet. Atwater stepped out of his canoe, his boots sinking into the slick, cold muck of the riverbank. The mud here is a deep, slate-gray smelling of sulfur and ancient sea life. With a shovel in hand, he began to slice into the vertical walls of the bank, peeling back the layers of time as if he were opening a dusty, forgotten book. What he found was a geological masterpiece, a repetitive, layered sequence that scientists now call the earthquake sandwich. At the bottom of this sandwich was a thick, dark layer of peat. If you were to touch it, you would find it spongy and fibrous, composed of the remains of grasses, mosses, and forest floor debris that had thrived hundreds of years ago. This was the original land, a lush, vibrant coastal marsh where spruce and cedar once grew tall and strong. But as Atwater looked closer, he saw that this dark peat did not fade gradually into the mud above it. Instead, it was cut off with terrifying sharpness, a flat, horizontal line that looked as though a knife had been drawn across the history of the earth. On top of that old forest floor sat a layer that did not belong, a ribbon of pale, coarse marine sand. This sand was the calling card of the sea. It was not the fine silt of a river, but the heavy, abrasive grains of the ocean floor, carried miles inland by a force of unimaginable power. In some places, this sand layer was only an inch thick. In others, it was a foot deep, still holding the delicate ripples left behind by a receding wave. Beneath the microscope, this sand revealed the tiny, broken shells of marine organisms that could only have come from the deep Pacific. This was the evidence of a tsunami, a massive wall of water that had surged over the coastline, suffocating the forest in an instant. But the most haunting part of the sandwich was what lay on top of the sand, a thick, suffocating blanket of tidal mud. This mud was the proof of the land's great fall. During the earthquake, the coastline did not just shake, it subsided. In a matter of minutes, the ground dropped by 3 to 6 feet, plunging the once-proud forests and marshes below the level of the high tide. The trees did not die from the shaking, nor did they all wash away in the wave. They died because their roots were suddenly, permanently drowned in the toxic, stinging brine of the ocean. Nearby, standing like skeletal sentinels in the marsh, are the witnesses to this catastrophe, the ghost forests. These are groves of western red cedar and Sitka spruce, their bark long gone, their wood bleached to a ghostly, silver gray by centuries of exposure to the salt and the sun. They stand upright, their roots still firmly planted in that buried peat layer, but they are dead, hollow shells of what they once were. These trees are rot-resistant, allowing them to remain standing for over 300 years as a grim monument to the night the land fell. When Atwater and his colleagues examined the rings of these trees, they found that the very last growth ring formed in the year 1699. The trees simply stopped growing after that winter. There was no transition, no slow decline. One year they were part of a thriving ecosystem, and the next they were immersed in salt water, their life cycles snapped shut by the arrival of the sea. The silence in these ghost forests is heavy, broken only by the occasional cry of a heron or the soft lap of the tide against the dead wood, a reminder of the ocean's slow, cold victory. As Atwater continued to dig, he realized that the sandwich he found was not a unique event. Deep below the layer from 1700, he found another sandwich, and below that, another. In the banks of the estuaries stretching from Northern California to British Columbia, the Earth held the memory of at least 13 major earthquakes over the last 6,000 years. Some sections of the coast showed evidence of these cycles stretching back 10,000 years. Each time, the process was the same. The land would slowly rise and buckle as the tectonic plates locked together, gathering tension for centuries. Then, in a single, violent rupture, the land would exhale, dropping several feet in an instant. The tsunami would follow, layering the drowned marsh in sand, and then the slow, quiet accumulation of tidal mud would begin again, burying the evidence until the next great shaking. On average, this cycle repeats every 500 years, though the intervals have been as short as 200 years and as long as 1,000. The ground we walk upon is not a solid foundation, but a stack of catastrophes, a vertical history of a land that is periodically swallowed by the sea. The implications of these layered sandwiches were staggering. For decades, geologists had believed that the Cascadia Subduction Zone was a quiet fault, one that slipped harmlessly and slowly without producing great quakes. But the soil told a different story. It spoke of a magnitude 9 earthquake that had once shattered the entire coastline, a rupture over 600 miles long. The evidence was no longer just a theory or a calculation. It was something you could touch, something you could dig out of the mud with your bare hands. The pale sand of the tsunami and the dark peat of the lost forest were the physical echoes of the same event that had sent an orphan wave to the shores of Japan. As the sun sets over the Kopali's River today, the shadows of the ghost trees lengthen across the marsh, casting long, dark fingers over the buried layers. The land appears peaceful, but we now know it is merely resting, held in a state of precarious tension. Beneath the beauty of the Pacific Northwest, the sandwiches are waiting, each layer a reminder that the ocean always returns for what it has claimed before. Out on the rolling gray swells of the Pacific, the research vessel moves with a slow, rhythmic heave, its hull groaning against the relentless pressure of the deep. Here, miles from the rugged coastline where the spruce trees cling to the cliffs, the water is a bruised shade of indigo, hiding secrets that have remained undisturbed for millennia. Chris Goldfinger and his team of scientists lean over the metal railings, their faces whipped by a wind that smells of cold salt and ancient decay. The sound of the ship's winch is a low, industrial hum, a mechanical heartbeat that vibrates through the deck plates and into the soles of their boots. They are reaching down into the darkness, deeper than the light can penetrate, toward the very floor of the world. They deploy a heavy, hollow tube known as a piston core, a massive steel instrument that acts like a geological lawn dart. It hangs suspended for a moment in the mist before plunging downward, slicing through thousands of feet of water until it strikes the soft, silty belly of the ocean floor. The impact is silent to those on the surface, but the result is a vertical slice of time, a long cylinder of mud that captures 10,000 years of planetary memory. As the winch begins to reel the line back in, the steel cable tightens, dripping with bioluminescent fragments and freezing seawater, bringing the ghosts of the past up into the harsh light of the modern day. When the core is finally winched onto the deck, it is a long, glistening pipe of plastic and steel, caked in the gray-green slime of the abyss. The air on deck is thick with the scent of sulfur and old earth, a pungent reminder that the seafloor is not just a place of water, but a graveyard of sediment. The researchers move with practiced, reverent hands to slice the core open lengthwise. As the plastic casing is split, a long ribbon of mud is revealed, smooth and wet, reflecting the overcast sky like a dark mirror. To the untrained eye, it looks like nothing more than a column of dirt, but to Goldfinger, it is a manuscript. He looks for the turbidites. These are the distinct layers that tell the story of catastrophe. Usually, the ocean floor accumulates a very fine dusting of silt, called hemipelagic mud, which settles at a rate of only a few centimeters every 1,000 years. It is a slow, peaceful process, like a light snow falling in a forest where no wind ever blows. But every so often, this peace is shattered. The core reveals a sudden, violent injection of coarse sand and gravel, a chaotic layer that cuts through the fine mud like a scar. These are the underwater landslides, triggered by the massive shaking of the earth, where the continental shelf loses its grip and sends a slurry of debris racing down the submarine canyons at speeds that would rival a highway vehicle. These layers are the fingerprints of the megathrust earthquakes, preserved in the silence of the deep. The analysis of these turbidites transformed the study of Cascadia into a quest for a hidden clock. By examining the thickness of the mud between each sandy landslide layer, scientists can estimate how much time passed between each violent event. It is a form of counting rings on a tree, but the tree is the very crust of the earth. One of the most vital markers found in these cores is a thin, distinct dusting of white glass and ash. This is the Mazama ash, the volcanic remains of the cataclysmic eruption of Mount Mazama, which occurred approximately 7,600 years ago. When that mountain exploded, creating what we now know as Crater Lake, it cast a shadow of ash across the entire region, and that ash eventually settled onto the seafloor. For Goldfinger, this ash is a golden spike in the timeline, a fixed point that allows him to calibrate every other layer above and below it. He can see exactly 13 massive earthquakes that have occurred since that volcanic eruption in the northern part of the zone. Each layer of sand is a testament to a day when the world shifted, when the ocean floor groaned and the mountains of the sea collapsed. The precision of this record is haunting. It reveals that the Cascadia Subduction Zone is not a sleeping giant that wakes at random, but a machine with a dark and predictable rhythm. The northern segment, stretching from British Columbia down through Washington, seems to rupture every 500 to 530 years, a heartbeat that is slow, heavy, and terrifyingly consistent. As the team moved their focus further south, toward the coast of Oregon and Northern California, the story written in the mud became even more urgent. In the southern cores, the layers are packed more tightly together. The landslides happen more often. The data suggests that while the entire 1,000-kilometer fault can rupture all at once in a magnitude 9 event, the southern section is prone to smaller, yet still devastating, magnitude 8 earthquakes that occur much more frequently. In these southern waters, the cycle shortens to an average of just 240 years. The researchers realized that the earth beneath the southern coast is far more restless than anyone had dared to imagine. They found 40 distinct earthquakes over the last 10,000 years, a staggering number that redefined the risk for every person living along the Pacific Northwest. Goldfinger's work took the abstract fear of an earthquake and turned it into a mathematical certainty. He could see the most recent layer at the very top of the cores, a thin deposit that matches the 1700 earthquake perfectly. It sits there, just beneath the modern surface of the seafloor, covered by only a few inches of fresh silt. That thin veil of mud is all that separates the present day from the last great catastrophe. It is a reminder that the clock has been ticking for 325 years, And the silence we experience today is merely the quiet tension of a spring being coiled tighter and tighter, waiting for the moment it must inevitably snap. Imagine standing in a laboratory, surrounded by these long, plastic tubes of history, the air cool and sterile. You run your finger along the plastic, moving through centuries with every inch. You pass the era of the Roman Empire, the building of the pyramids, the dawn of human civilization, all represented by a few feet of gray sediment. And then, your finger hits a layer of sand. You are touching a moment of absolute terror. You are touching the physical remains of a tsunami that once scoured the coast, of a shaking so violent that it liquefied the soil and sent mountains of silt tumbling into the abyss. There is a weight to this knowledge that transcends mere science. It is the realization that we are living on a landscape that has been broken and remade dozens of times. The cores do not lie. They show that the interval between quakes can be as short as 200 years or as long as 1,000, but they never simply stop. The machine is always running. Goldfinger often speaks of the confluence test, where they look at different canyon systems to see if the landslides happened at the exact same time. If multiple canyons hundreds of miles apart all dumped their sediment into the deep-sea channels simultaneously, there is only one possible trigger: an earthquake of such scale that it gripped the entire continent. The evidence is overwhelming. The seafloor has kept a perfect diary of our future, and as we look at the empty space at the top of the newest cores, we realize that the next entry is already being prepared by the shifting plates beneath us. The laboratory fades, the scent of sterile plastic and ancient mud giving way to the sharp, bracing air of the Pacific coast. We are no longer looking at the layered records of the past, but at the invisible, frantic pulse of the present. High above the rugged cliffs of Washington and the misty shores of Vancouver Island, a network of silent sentinels watches the world. These are not people, but machines, precise, unblinking instruments of the Global Positioning System, or GPS. Imagine a concrete pillar, white and weathered by the salt spray, driven deep into the ancient, unyielding bedrock of the Olympic Peninsula. On top of this pillar sits a small, rounded dome, a plastic shell that houses an antenna reaching out toward the cold vacuum of space. It listens. It whispers to a constellation of satellites orbiting thousands of miles above the turning Earth, capturing signals that tell a story far more immediate and far more terrifying than the silent cores we left behind. In the late 1980s and early 1990s, when these stations were first planted like seeds along the edge of the continent, the scientists expected to see the slow, steady drift of the plates. They expected the rhythmic dance of geography. What they found instead was a slow-motion collision that is currently reshaping the very ground beneath your feet. Inside the quiet halls of the Geological Survey of Canada, the air was heavy with the hum of early computers and the faint, ozone smell of electronics. Scientists like Herb Draggert began to notice something strange in the data streaming in from the coast. As the dots were plotted onto maps, a chilling pattern emerged. The coastline was not stationary. It was moving, but it was not drifting away into the sunset of the Pacific. It was creeping inland toward the heart of the continent. Imagine the entire edge of North America, from the surf-beaten rocks of Tofino to the dense forests of Northern California, being shoved eastward. The GPS stations at the water's edge were recording a steady, relentless march toward the interior, moving at a rate of several millimeters every single year. At Cape Meares in Oregon, the land is sliding northeastward at 10.5 millimeters annually. It is a slow, agonizing crawl, a continent being forced to retreat by the invisible hand of the Juan de Fuca plate. Since the last great rupture in the year 1700, this coastline has moved more than 3 meters inland. The land is being compressed, shortened, and squeezed like a giant tectonic vise. But the horizontal movement is only half of the mystery. As the scientists looked closer at the vertical data, they realized the coast was also rising. It is as if the very crust of the earth is inhaling, a slow and deep breath that has lasted for 3 centuries. Along the western Olympic Peninsula, the ground is being pushed upward at a rate of 4.5 millimeters per year. If you were to stand on those ancient, moss-covered rocks and remain perfectly still for a decade, the earth would lift you nearly 2 inches higher into the sky. This is the bulge. Because the 2 massive plates are locked together, unable to slide, the subducting oceanic plate is wedging itself under the lip of North America. It is not a smooth descent. Instead, the edge of the continent is being caught, snagged on the rough back of the diving plate. As the oceanic slab continues its journey downward, it drags the edge of North America with it, causing the crust to buckle and arch. The coastline is being forced upward into a long, slow-motion wave of rock and soil. It is a terrifying realization that the ground is currently storing the energy of 1,000 coiled springs, a physical manifestation of a tension that has no easy exit. Visualize a thick, heavy rug lying on a hardwood floor. If you place your foot on one end and push forward, the rug does not slide easily. Instead, it catches. As you continue to push, the fabric begins to bunch up, forming a series of ridges and folds. This is exactly what is happening to the Pacific Northwest. The North American plate is the rug, and the Juan de Fuca plate is the force pushing against it. The ridges are the mountains and the rising coastline, bulging under the strain of a force that will not stop. Every millimeter of uplift, every fraction of an inch that the coast moves eastward, represents more energy stored in the rocks. The silence of the landscape is deceptive. Beneath the tranquil beauty of the evergreen forests and the crashing waves, the earth is screaming with tension. The plates are fully locked, fused together by the immense weight of the ocean and the heat of the deep crust. They have not moved an inch relative to one another at the interface for 324 years. The pressure is building in the darkness, a heavy, suffocating weight that grows with every passing second, waiting for the moment when the friction can no longer hold the continent back. In the midst of this terrifying stillness, scientists discovered a ghostly heartbeat. They call it episodic tremor and slip. Deep beneath the surface, far below the locked zone where the great quakes are born, the plates are doing something strange. Roughly every 14 months, a series of tiny, silent tremors begin to ripple through the deep crust. They are too faint for a human to feel, but the GPS instruments catch them with ease. For a few weeks, the deep part of the fault begins to slide backward, releasing just a tiny fraction of the built-up stress. It is a rhythmic, almost musical pulse of the earth, a sign that the depths are moving while the surface remains frozen. But these silent slips are not a relief valve. Instead, they are an omen. Every time the deep section slips, it transfers that stress further up the fault, pushing it into the locked zone where the pressure is already at its limit. It is like adding a few more pounds to a bridge that is already on the verge of collapse. We listen to this heartbeat, this rhythmic ticking of a tectonic clock, knowing that each pulse brings us closer to the final snap. We stand now on a shoreline that is literally rising beneath us, a continent being shoved inland by a hidden, relentless enemy. The data from the GPS stations is clear and undeniable. The spring is coiled, the bulge is growing, and we know from the laws of physics that what goes up must eventually come down. When the friction finally fails, when the locked zone can no longer withstand the weight of the Pacific, the bulge will vanish in a matter of minutes. The land that has spent 300 years rising will suddenly drop. The coastline will subside, falling 5, maybe 6 feet in an instant, as the continent springs back toward the sea. The very ground you walk on is a temporary high, a precarious peak held up only by the sheer force of a collision that is overdue for a release. The silence of the coast is the silence of a held breath, a moment of absolute tension before the inevitable exhale. We are living on the edge of a snap that has been 3 centuries in the making. and the Earth is giving us every sign that the time is drawing near. The tide is pulling away now, leaving the mudflats of the Washington coast gleaming like hammered silver under a bruised, late-afternoon sky. If you stand very still near the mouth of the Copales River, the only sound is the rhythmic, distant roar of the Pacific and the occasional cry of a gull circling the salt marshes. It is a landscape of profound peace, yet it is here, among the skeletal remains of the ghost forests, that the longest shadow of all begins to stretch across the present day. These trees, mostly western red cedars, stand as silver-gray monuments to a single, violent moment that occurred over 3 centuries ago. Their bark is long gone, stripped away by decades of salt air and rain, leaving behind twisted, weathered trunks that look like bones rising from the silt. They are silent witnesses to a geological cold case that took hundreds of years to solve, a mystery that remained buried beneath layers of river mud until a few dedicated individuals began to listen to what the Earth was trying to tell them. The silence of these marshes is not empty. It is a heavy, weighted thing, filled with the memory of a world that changed in the blink of an eye. One of those voices belonged to a man named Brian Atwater. In the late 1980s, he could often be found paddling a small canoe through these tidal marshes, not for recreation, but to perform a kind of forensic autopsy on the land itself. He was looking for evidence of a sudden, catastrophic change. With a simple shovel and a keen eye for the subtle layering of the Earth, he began to uncover a recurring pattern in the banks of the estuaries. Beneath the living marsh grass was a layer of dark, organic peat, and directly on top of that peat was a thick blanket of gray sea sand. This was the signature of a disaster. It told a story of a coastline that did not just erode or shift, but one that dropped vertically by several feet in an instant. The ghost forests died because their roots were suddenly plunged into salt water as the land sank, drowning the cedars where they stood. Atwater's work, conducted with the patience of a craftsman, proved that the Pacific Northwest was not a geologically quiet corner of the world, but a place that lived on a hair trigger, waiting for the next great release of tension. He found evidence of many such events, stretching back thousands of years, each one leaving a layer of sand like a page in a dark, dusty book. While Atwater was digging in the mud of the Americas, halfway across the world, a Japanese seismologist named Kenji Satake was poring over ancient scrolls and village records. He was hunting for the origin of an orphan tsunami, a massive wave that had struck the coast of Japan in the year 1700, without any accompanying earthquake to warn the local residents. For centuries, this event was a ghost in the archives, a ripple with no stone to call its own. But when Satake compared the Japanese records with the tree-ring data from the ghost forests, the pieces of the puzzle clicked into place with terrifying precision. The Japanese accounts described a wave arriving on the 27th of January, 1700. By calculating the time it would take for a tsunami to travel across the vast, dark expanse of the Pacific, the scientists were able to pinpoint the exact moment the Cascadia Subduction Zone finally snapped. It happened at approximately 9 p.m. on the evening of January 26, 1700. It was a magnitude 9.0 event, a rupture that stretched for 700 miles, changing the face of the continent forever. The mystery was finally solved, but the solution brought with it a new kind of weight. Today, that same fault line lies just off the coast, hidden beneath miles of dark, cold water. But we are no longer blind to its movements. Across the hills of Oregon and the mountains of Washington, a network of highly sensitive global positioning sensors is humming in the silence. These instruments are so precise they can measure movements as small as a few millimeters. And what they are telling us is that the land is still moving. Right now, as you listen to my voice, the coast is being shoved eastward and upward, compressed like a giant spring. The Juan de Fuca plate is sliding relentlessly beneath the North American plate, but they are not sliding smoothly. They are locked together, snagged on the rough edges of the Earth's crust. This is the interseismic phase, a period of quiet accumulation. We are living in the space between the last breath and the next. The scientists tell us that we have entered the window of time where another rupture is possible, as these events tend to happen every few hundred years. The sensors watch the slow, invisible dance of the continents, recording every millimeter of tension as the bow is pulled further and further back. Living in the shadow of such a giant requires a different kind of perspective. It is a reminder that the human timeline is but a flicker compared to the slow, heavy breathing of the tectonic plates. We build our cities, our bridges, and our homes on a surface that we imagine to be solid and eternal. Yet the geology of the Pacific Northwest teaches us a lesson in humility. There is beauty in this knowledge, a sense of being deeply connected to the primal forces of the planet. We prepare not out of fear, but out of respect for the power that shaped the rugged cliffs and the towering evergreens. The legacy of the scientists who solved this mystery is not just a warning, but a gift of time, the chance to understand the ground beneath our feet and to protect the generations that will follow. The shadow is long, but it is cast by a landscape of incredible majesty, a place where the mountains meet the sea in a dance that has lasted for millions of years. We walk upon this land with a new awareness, knowing that the peace of the coast is a fragile, precious thing, earned through the long silence of the earth. The air tonight is still, and the world outside your window is resting. The heavy questions of the earth's deep history can wait for the morning light. For now, let the image of the quiet coast fill your mind, the way the moonlight reflects off the damp sand, and the soft, white foam of the waves as they reach for the shore. The tension of the plates is a slow story, unfolding over centuries, far beyond the reach of this single, quiet night. You are here, in the safety of the present, surrounded by the familiar comforts of your room. Let the weight of the day lift from your shoulders, sinking away like the tide. Everything is as it should be. The case rests now. Let the details fade. You are safe. Close your eyes, breathe deeply, and have a good night. Sleep well.